over 3. 1, 2, 3. 22.15 negative degrees per second. So we had negative 22.124, negative 22.15, and one more. 49.99778 minus the 50. Negative 0.00222 divided by 0.0001. So moving it over 4 places, negative 22.2 degrees per second. So I think we're really zeroing in on the rate of this door here. Looking like negative 22.2 something maybe if we went one more, but again, we're close enough. All three of these were in the negative 22s. So our estimate for the rate of change is a negative 22.2 degrees per second. And again, what is this negative telling us? And hopefully you guessed that that means the door is closing, and you are correct. If you look back at the graph, get that so you can see it there. And if I trace to 4, enter, you can see I'm right kind of in the middle here where it's coming closed. So yes, so the door is closing at this rate. Okay, so what this idea is that we did here, well, doing this rate of change business, where we're taking the y values, change in y values, and dividing by the change in the x values, is called a derivative. So what we just found is a derivative. A derivative is a rate of change. The process we went through to get a derivative was to divide the change in y values. I'm talking about what's on the y-axis of our graph. In this case, it was the degrees, so we subtracted the degrees to get the change in degrees. So divide the change in y values by the change in x values. And our change in x values were time, and that's our label. We took the change in degrees and divided by the change in time. So that's how you can get your label on these problems. Whatever is on the x-axis and whatever is on the y-axis, that's what's going to be divided here, except it's y divided by x. Okay, so what we found was a derivative. And like I said, this derivative is an estimate. And when we get into calculus, we'll be finding ways to find the instantaneous rate of change without going through this laborious process here. So the derivative, and you can see if we keep going, we will keep getting closer and closer and closer to a value. Depends on how far we carry these out, but it's called a limiting value. You keep getting closer and closer to a single value. So it's the rate of change, and this is how you get it. And I don't think I want to write that. I think I'm good. All right, so tomorrow when you come to class, we'll be working on the homework here. Oh, I don't have the book. And this section's pretty short. It's going to be page 5, problems 1 and 2. So this is what you'll work on in class tomorrow, or if you want to work on it tonight, go ahead, you're just ahead of the game. But you'll have no problems finishing this in class, and then I'll have the next video ready for you that night. Okay. Where is it? Where is that thing at? Can't remember how to stop it.